Hi, Mrs. Beeble here. I'm at the park with my daughter, so if you hear some strange noises in the background, that's probably what you're hearing. What we're going to do today is we're going to take a look at this problem right here, and we're going to really focus on getting used to writing our expression as we're simplifying. And this is really the next step in leading us closer and closer to solving equations, and some very complicated equations at that. So what I do is I usually start with something called an LRE. I make a table, or I make a chart with a left, a right, and an E, or an L, and an R, and an E, separated by lines, and just to kind of keep track of where I'm at in this process here. So once you have your LRE created, and the next step would to just be write out what is given. So we're going to start with this left-hand side. What has been given to us here? Well, up on the top we've got negative 2x plus negative 3 plus 1. And then here's the part that people tend to struggle with a little bit. So that's that whole first part. Is now we're going into that negative region, that lower region, and down there, in parentheses here, we've got a negative x plus 3. Same thing then with the right-hand side. Up on top, we've got the 2 plus the negative 3. And then we're going to that, dipping down into that negative region, so that's where that first negative sign comes in. We put parentheses, x, and minus 2. Or if you had plus negative 2 there, that would be the exact same thing. And that's just given. And that's what the E stands for, is the explanation. Well, this was given to us. So the first step we're going to take in the actual simplifying of this is we're going to use a move called fool. I call it fool anyway. It's called flip the opposite over the line. And that's just what you've been doing in class. You've been taking all this stuff in this negative region and flipping it up into that positive region. But in order for us to do that, we have to first click these so they're the opposites of what they were, and then we can drag them up. So we just flipped the opposite over the line. And we're going to do the same thing over here. Flip these to make them the opposite, and we're going to put them over the line. And that's why I call it the fool move. So now what I want you to think about is, now how is this expression going to change? What's going to change on the left-hand side? How is that left-hand side's expression going to look different? And you're going to be asked to answer that question here in just a little bit. All right, so now you should know whether or not you were correct about that left-hand side. And now I'm going to have you do the same thing for the right-hand side. How is that right-hand side going to look different when we uncover this? What is going to change about that expression? Go ahead and answer that question now. All right, so you should have seen that one of the things that's going to change on this left-hand side, there's no parentheses anymore. And instead of a negative x, we have a positive x. And instead of a positive 3 being added to these positive 1 tiles that we had, we ended up with 6 negative tiles because those flipped over to negatives. The same thing over here. Instead of having a positive x, we now have a negative x. And instead of negative 2 tiles when it got flipped, we now have 4 positive. We added it to that. And you may not add those all at once, but most of the time when we fool, we tend to combine those at the same time, but you don't have to. All right, next step. What we're going to do next, and this is usually what I do anyway, is I get rid of those 0 pairs. So anything in here that's a 0, here's a positive 1 and a negative 1, that makes a 0. A positive x and a negative x, that makes a 0. So I'm doing something called an RZP. I'm removing 0 pairs. What is the expression for my left-hand side now? All right, let's do the same thing for the right-hand side. Let's remove our 0 pairs. We're doing that. So you're hearing all sorts of great noises. Sorry about that. And now write the expression you have left on the right-hand side. All right, so this is what you should have. Negative x plus -5 and negative x plus 1. And again, that can be in any order you want. It could have -5 plus x, negative x, sorry, or you could have -5 minus x. Or here you could have negative x minus 5 instead of plus -5. It all means the same thing. And we did a move called RZP, or removing zero pairs, or some people call it combining like terms, which is essentially what we're doing too. We're combining some like terms. All right, now, what would you do next? What is the next step you would take in simplifying to decide which side is larger than the other? Answer that question now. All right, I'm hoping you chose that you would take your like terms off of each side, the equals from each side. So I have a negative x over here, and I had a negative x over here. I can remove those from each side because they are equal to one another. And what we end up with is -5 tiles on one side and 1 positive tile on the right-hand side. And that move is called a Reese, removing your equals from each side. Okay, so now you should know then that -5 is less than 1, so the right side is larger. Great job, everybody.